tool to create a PCB thieving pattern. First, we will create a dummy net to assign the polygons we're going to create. We will need this in order for the via stitching tool to work. So we'll just add a new net. We will call it thieving temp and go ahead and hit OK. With this net created, we now have it available to go ahead and assign to the polygon that we'll need to generate. Using Tools, Polygon Pores, Polygon Manager, we'll go ahead and bring up the Polygon Pore Manager and use this to create a new polygon using the existing board outline. And we'll assign this polygon to the bottom layer, give it a descriptive name, and assign the net to the thieving temp net that we created. Go ahead and disable these as we don't need them, and hit OK, and OK again to go ahead and generate this polygon. With our polygon created, we're going to go ahead and now select the polygon. We want to move it out from the board area. To do this, we're going to use the move selection by XY to move it a very specific distance off to the right of the board in this case. We do not want to rebuild the polygon after this movement. It's important that this particular polygon keep its shape. The next thing we want to do is make a copy of this polygon. We'll go ahead and place this onto the top layer. Using the paste special command, we'll set the top layer, go to edit, paste special, and we want to make sure that we have enabled paste on current layer and keep net name. And when we paste this onto the layer, it will go ahead and place it there. In this case, we do want to rebuild the polygon. This will place it on the right layer and give it the two sides that we need in order to be able to stitch these polygons together. The gaps left on the bottom layer will ensure that we get the proper stitching. Next, we'll go ahead and bring up the via stitching command. And then from here, we'll go ahead and set the parameters. We want to assign this to the thieving temp net that we created. Give it a proper grid value. In this case, we do not want to stagger the rows, so we'll leave those. The clearances here should be fine. We do want a hole size of 0, saves us from editing it later, and I do prefer to give a kind of a fractional diameter in case we need to search for that specific diameter size later using find similar objects or a similar tool. Now that we've created our vias, we want to go ahead and select them, and we're going to convert them to free pads. Maybe change their shape a little bit, but at this point we're actually turning them into the thieving pads. So we select the vias, go to Tools, Convert, and we convert the vias to free pads. Once they are changed to pads, we can now put them on a single layer. We're going to first store them in the selection memory so that we can recall these pads later. We'll probably want to change them again. We can then bring up the Object Inspector using F11. First thing we'll change is the layer. I wanted this for the bottom layer, which is why we started with that polygon. So we move those first to the bottom layer. Hole size already was 0. Because these are surface mount pads, we do want to override the paste and solder mask. So I'm just going to give those a large negative value to make sure that there is no paste or solder mask applied for these pads. And I actually want a diamond pattern, so we're going to go ahead and change the shape of the pads from round to rectangle. And then with the rectangle pads, I also want to go ahead and change the rotation again to give it that diamond shape. We're going to rotate these by 45 degrees. I do want these diamond shapes touching, so I'm going to also increase the X and Y size. Again, this is all done using the PCB Inspector panel. The final thing we'll want to change will be to remove the net name from the pads. Forgot to do that, so let's bring up the PCB Inspector panel, remove that temporary net name and set them to no net. And go ahead and close that inspector panel. And at this point we're going to again use the edit, move selection by XY, and we can now reverse the movement we made earlier to go ahead and place this pattern directly onto the PCB where we started with the original polygon. And we can now remove the polygons as we no longer need them. And this process can now be repeated on any signal layer. The important part being that we start with the polygon on the layer that we want to place the thieving pattern. As a final step, let's go ahead and recall the selection memory that we made earlier. And we can go and right click on one of these selected paths, access the unions menu, and create a union from the selected objects. This allows us to then move these objects as a group. The selection memory also